Hello everyone, I'm Albert Chen and I'm an ambassador from Overseas Protocol. I'm happy to share here today in Taipei Blockchain Week. And my topic is about privacy preserving and verifiable off-chain computation. And this is all powered by Overseas technology. So in today's topic, I will focus on the intersection of AI and blockchain. So with AI, we bring more convenience automation to our ecosystems, but what about data privacy? And also AI is a computational heavy task, so how about the computational trust? So as for me, AI is a double-edged sword. It brings us efficiency, automation, like you can have your on-chain portfolio management to find a high yield or even a high performance token layer. And it also can have some auto rebalances mechanism based on AI strategy. And also it brings some data insight like on-chain data processing. It can fetch all your past data and give you some insight about what you should improve or what you should follow to like copy other people's past transaction. And also it can quantify the user influence. Like Kaito, they quantize the user's posts on Twitter and give them some rewards based on trend. And the third is personalization. You can build your recommend system by your on-chain or off-chain data. And also, even more, you can base on all your action and build an agent that just like your digital twins act as what you actually do. But for the disadvantage, they'll come to data privacy. Is your personal data safe during the computation? Is there any like the server will send your data back to the backend for storage or for the AI model fine-tuning, something like that? And the second one is computational trust. Can we truly trust the result get it from an AI provider? Is it actually from an AI provider or not just their people to modify and give you some malicious result from it? So here is why we need a blockchain. The cornerstone of decentralized trust. Blockchain brings us immutability. Like once on chain, data cannot be altered. And also decentralization, no single entity can control it and prevent a single point of failure. That even one node is deprecated, still have different nodes to maintain it. And the third is advantage, also disadvantage, like transparency. All computation and transaction are public verifiable. Verifiable is good for us, but should it always be public? And the fourth part is data sovereignty. It gives us a true ownership of our data. So it gives the authorities from different like AWS, Google back to our own self, so we can control our own data and even monetize it to sell it to other platform or like AI model trainer, something like that. So just give a quick summary. Blockchain provides a fundamental of trust and ownership for AI. But how about the privacy and trust for the heavy computing? So here is why Oasis stands out. Oasis solves these two biggest challenges for AI in Web3, privacy and trust. For privacy, Oasis offers confidential EVM allow developers to build the app that process sensitive data while keeping it completely private. And also it is the first and only EVM that supporting this. So if you want to build something private app and you don't want to need to learn a new language, you just want to write Solidity and also EVM compatible code, just use Oasis. We enable a new class of decentralized privacy application. For trust, Oasis Ruffle framework allow complete AI computation. It's not only AI, you can run any heavy computation on it. So it will perform in off-chain, but provide a verifiable cryptographic proof that's submitted to our Sapphire blockchain, and this ensures that all the results are trustworthy. So it combines your off-chain performance with the on-chain trust on it. So you no need to run all the parameter on-chain. Yeah, and you can see that this is our Oasis architecture. At the top is consensus layer. It's just for government and token transfer and some things. And for the computation, it goes to the down layer like compute layer. Most of the things in compute layer can be the blockchain, like Sapphire, Emerald, Sapphire, and also what today we will focus on is the Sapphire, the confidential EVM. The state of the smart contract layer is being encrypted. And between the consensus layer and compute layer, there is a verifiable computing. It's also called Ruffle. You can run your off-chain logic on it and push your proof back to the Sapphire blockchain and make all things trustworthy and secure by the cryptographic proof. So let's just start introducing the first about privacy, Oasis Sapphire. And before this, we will introduce like what is TEE, and this is all our fundamental of how we build the Ruffle and also Sapphire. So this is the message that's copied from the wiki. So just take a quick look. A transaction execution environment, a secure area of the main processor. It helps the code data loaded inside it to be protected with respect to confidentiality and integrity. So data confidentiality prevents unauthorized entities from outside the TE from reading the data. So once your data is stored and encrypted on-chain, only the TE can get the data. No other unauthorized entity can get it from it. And while code integrity is that it prevents the code in the TE from being replaced or modified. So they will make sure that the code is not be any change on it by any unauthorized entity. And we will also store this code hash and some computation to our Sapphire blockchain, so it should be matched on it. So which maybe also be a computer order itself as in a certain DIN schema, like described in Intel SGX is one of the famous and common TE hardware machine. So let's introduce our Oasis Sapphire after we know that TE brings us confidentiality and also integrity. So Sapphire is a confidential EVM compatible chain. EVM is important that if you previously write any Solidity or write any code on EVM and you currently want it private, you just bring it to Oasis Sapphire and we can provide you with the same developer experience when you develop your app. And another is smart contracts are executed in the TE. And this TE is also on a distributed network of compute nodes. So your TE is not only run on one node, it's run on a few, but some node on Oasis blockchain. So you do not afraid about once the TE deprecated, the data will go appear because it's not no single failure. So it still has different nodes to run it. And the third and also the most important part is like smart contract storage is encrypted. So no other party without you can use the get function to get the smart contract data out from it. So it's private confidentiality. And the final part, smart contract transaction and call are optionally. Which called optionally is that you can choose your transaction and call you interact with RPC client should be encrypted or not encrypted. This encrypted is by the end-to-end encrypt by the ECDH key sharing. So what this brings us, it prevents us from a side channel attack, so no other people can listening to our request and get some information back to it. And just quick look about all the feature and client-side of Oasis Sapphire. Oasis Sapphire brings us a feature like encrypted contract state, end-to-end transaction encryption, EVM compatible, and also all run in the TE. As for the client side, we provide you with a Sapphire wrapper, which is in many different languages like TypeScript, Go, and also Python. So it's available for you to interact with our RPC. If you want to choose to have an end-to-end encryption with our client side, you can use this wrapper to exchange your key with our client side and make it all encrypted. And what you should know is to just download our package and you can have all this functionality. And another is we also write some special and also useful library on our Sapphire Solidity contract. So it's all from the DE. So this provides some useful and distinct on-chain tools for developer, including the random number generation, key derivation, signing with Ethereum, something like this. So let's take a look about all of these cool tools. So the first one is random number generation. It's good for gaming or any place you want to have some random environment there. So you can see that in the screen, you just import Sapphire Solidity and get a random byte on it, and you can directly get a random seed. And based on random seed, you can create a lottery or like any gambling games or something like that. And the third is on-chain key generation. We also write different algorithms, so you can choose any algorithm you want. If you want to interact with Solana, we have ED25519. If you want to interact with different blockchain, we still have their algorithm. And what you need to do is just on-chain key generation and call a generate sign key pair with your choose algorithm and a seed. So, and also we can use this secret key, the key you generate, to encrypt your data and get back from it. So you can see that here can encrypt and also decrypt your data layer. So all is you can conduct with our blockchain and store in privacy into our blockchain and get your cool cross-chain of application or something like that. And here is also like a signing. So on the last PowerPoint, we see that we can create a new key, and we can also use this key with sign message to sign it. And you can, like what you send a transaction like that, you can sign the message and get a signature back to you. And you can see that it's just like a Sapphire signing, and you can sign all the data you want, and you can even send to a different country there. And this part is for like signing with Ethereum oath. If you are a developer, you are familiar that it is very common in when I want to enter some DApps, but we write the sign in with Ethereum on the contract. So you can directly send your signing message with a get function to get your actual state on the blockchain, since all the state is private. So you can in your smart contract logic to choose that who can decrypt it, and by the signing with Ethereum to get the identity verification. So only the true person with a true signature can decrypt your data and get back from this function, like get secret message. This is simple contract that write based on our second with Ethereum of oath. So you can just write this and have a special function that only user send a message can get back the secret message back to them. So I think in this part we introduce many privacy preserve and also the cool like functionality based on software. But what about the expensive computation and storage? Is it necessary to run all computational on-chain, or we just put it off computational off-chain and build like a verifiable proof to send it back to on-chain and have a trustworthy environment? If you think the later is the solution, then that is what Oasis do. So let's take a look on our Ruffle. And Ruffle is not a meme. It's for like a small character from the runtime off-chain logic. So let's take a look at Ruffle. It also uses T. T is a fundamental of Sapphire and Ruffle technology. So we use T to securely and confidentially run your Docker-inspired Ruffle app. So it's Docker inspired, so you can write anything. If you just build it into the Docker image and use Docker Compose to architect it, and you can build it on Ruffle. So it's no like language constraint. You don't have to even learn a new language. So you can build it in a Docker image and run it on Ruffle. And the second part is don't run Ruffle on all the nodes, but on an arbitrary small set of nodes. It's for the scalability. Since that if you run on an all node will execute all your transactions, but it's not necessary. But for you to run on one node, that if that node is deprecated or it's broken, all the data will lose. So just choose arbitrary small set of the node for scalability and also for the prevent for a single point of failure. And the third, it allows Ruffle to access the internet. It's also the important part that you can if you can access to the internet, you can request to the different blockchain state, and also you can get the Web2 data back to the Web3 chain. You can build an oracle. You can get your past transaction. What you can do more things, just like what you actually do it on current Web2 ecosystems. So you bring all the Web2 and even different Web3 blockchain back to your app. And the fourth, like client can communicate directly with Ruffle instance, but only when the node operator are willing to expose their code. So if you want to directly communicate with Ruffle, you should choose the node operator that support this functionality. And the last part, use Sapphire to store secret and to manage your Ruffle. So all the registration, configuration, deployment, building, authorization, and also secret key storing is on the Sapphire. So all is on the private confidential EVM like Sapphire. So you should not afraid that the data will be leaked. And also we will put Ruffle the confidentiality, and you should make sure that what you register on Ruffle is actually the same that the T executing your Docker. So we will put also Docker image hash, your secret key hash, and put it back to the Sapphire to compare that whether they are the same to meet the integrity layer. So what Ruffle is for? It's ideal for a compute-intensive app, like an AI app that need to be trusted like an Oracle and also app need faster response time like gaming. So if you want to build any intensive computation AI inference, or you want to build you want to get weather or Web2 like data and quickly back to on-chain, you can use it to build Oracle. And if you want to play the gaming, yeah, you can also use our data and put all the data back out from the blockchain, but still verifiable through Raffle app to put the cryptographic proof back to the Sapphire blockchain. And let's take a look from, I think this is the Oasis node, their view of all the Raffle system. So Oasis node will run your Raffle app in the TEE. And in your container, you can send any request to the Web2 service and get back data from it. And what you should do is you should register back to the Sapphire blockchain and get a secret which should update it onto the Sapphire blockchain back to the container. And in your TE, you still can send any transaction by our built-in package like app, sock, rest. You can send any transaction based on this component. So you can interact with Sapphire and keep all the data secure and confidential in the node TEs. And let's take another look. It's from the developer. So for the developer, they have to rent the machine to deploy their Raffle app. So it ran it on the Oasis Sapphire and also registered it whether they plan how many CPU or how many storage they want to use. And we also can configure this in our Raffle YAML, so I will show you later. And once we registered it, the different node can execute it and give you a result, and the proof to prove your result is actually from the T model, T machine that is all trustworthy. So the raffleized step is just like this one. The first is initialize, and it's like your application will architect with the Docker Compose. So you should have a Docker Compose YAML, and inside that, you can have your own Docker image, or if you want to integrate AI, you can also include Llama to image or Llama or something like that and use Docker Compose to architect all the application and build it inside. And next, it needs your Raffle app, and it will also get back like a Raffle ID back from you. So once you init and register it on-chain, you will get the app ID. And another is you can build your Raffle bundle for particular network. You should specify whether you are deploying on mainnet, testnet from it. And currently, I think it's supporting Sapphire testnet and Sapphire mainnet. And also, you have to store your secret. So we will not store the secret directly into the TE. We will store the secret to the Sapphire blockchain. So the blockchain store our secret, and our Docker Compose running TE will fetch the state back from the Sapphire blockchain and get the decrypt state on it. So only the TE can decrypt it. And after we build all the things like the secret, the Docker Compose, raffleize all the things, we can deploy the Raffle to our Raffle TE provider. So let's just build your first Raffle. And take a look. And we will focus on the quick start of Oasis blockchain. So just let me change my screen. And wait a minute. So let me setting up my app. Yeah, I think it's all perfect here. Yeah. Yeah, maybe I can. CD to Oasis layer. Oh, sorry. Yeah, maybe I can make this more bigger. And you can follow the quick start on Oasis document to build your own and first like Oasis RAP4 app on it. So today we will introduce how to build a Python Telegram bot, and it's pretty easy. So the first is usually create an environment and just put some requirement on it and install all the instance. So let me create a workshop, like create a workshop for it and cd into it. Yeah. So we will create an environment for our Python code. Yeah, all things done. And another, we will have to build another file that run actually our logic layer. So it will importing the OS, and you can see that the function is that if you call a hello, like a slash hello, and you will get all the requests by hello, and you will get your name and back to you. And this all what it do. Yep. Let's store all the things and maybe check again whether we are. Yeah, all things good. So since that we have to interact with our Telegram bot, so before this one, you should you should start check that whether have this requirement or not. So the first requirement is that you should have a Python, and you should also have like the Telegram bot token that help you to interact with Telegram by a Python code, and also you have to have the Oasis CLI, and it's very easy now that you have to only use brew install Oasis, and you can get it from like your platform, and you have also have your Docker to run some code on it. And another way here is like because you have to run the Oasis Raffle node, so you should get some test token, and here have a link. And if you want to get the Oasis CLI from native, you can also get the Git repo here. So let's just start it and keep going. I think that the next step will directly run our token here. So what we have to do here is to change the token back to what we actually do. So we have to get a token from like a Telegram bot. So let me get from my Telegram bot. And yeah, you can go to the Telegram bot and have your bot to chat with your bot further and get your token there. And here is my token. Wait a moment, I get it from. Yeah. And you can see here that you can slash new bot, yeah, and give a name like I want it be the Oasis bot, and maybe Oasis bot 04094 bot. Okay, I think Joki uses this. Yeah, and here we got the SS token here, and we just put it here to say that our token is this one and try that whether our bot is working or not. Yeah. And just go here and start it. Yeah. I think we use hello to test. Yeah. It's worked well that it get my first name back to me. It's what all I write it in the bot.python's code. So after you build your Python, and you can also Dockerize into the Docker image. So now let us create another Docker image here. So what you have to do is to create the Docker file. And store it. Check it again whether it's going well or not. Yeah, all things correct. And after you build your Docker file, you should also have the Docker compose to architect it. So we also create a Docker compose. Oh, I think it's compose YAML. It's okay. Yeah, and here the token did not directly send to node. It will fetch it from Oasis Sapphire, and we will mention later. So store it. And now we can use Docker compose to build and up it, and we can test it at whether all the things right cool. In this part, it's just to test that your Raffle app is working well or not. Yeah. Oh, but now in the Docker compose, it run the the already built image and also public image from Oasis protocol, so you can check that. Because Node will not have your code, so you have to make your image be published and also public for all the nodes to store. So here we use its image and from the Oasis protocol. And if you want to build your own, you should just put it onto the GitHub and make it public and just write in your Docker compose, and you can also write many like Python Telegram bot or Olama here and run all the logic and architect by the compose YAML here. And at the last part, we test that the Python Telegram bot is running well here. So what we will do next is to init our Raffle. So if you not already install Oasis, you can use brew install Oasis. And I already installed it, so I just test it and run Oasis Raffle in it. Yeah. And another part is Oasis Raffle create. And we also said that we should specific at whether which chain we need to be pointed to. So we choose testnet. Yeah. And you will ask you to send a transaction and meta confirmation by the Sapphire blockchain. So just wait for it to blockchain it to broadcast it to the model. Okay, so now the problem is that we have to run the machine, but we did not have enough token. So also, basically, I did not know which wallet I pointed to, so we just listing. If you do not have any like wallet here, you can create a wallet by Oasis wallet create and put your name. If I want to be like 2. And also you can list it to check whether it run well or not. Okay, but now default is forever, so I just Oasis wallet set default over 2. Yeah, and check again. Now our default is Raffle Albert 2. So you can create your own wallet here and make sure that we should go here to get some token. Choose a Sapphire and your address here and request test token from it. So after you successfully submit your Raffle facet request, you can create your own Raffle based on that token. So just wait a second and let's go. So now you can find that account here is over 2. And we already got a facet from it. So also see here have a transaction hash. So the part here we have to go to the Explorer and check whether it's successfully displayed or not. But I think it's successful, so just check it. Yeah, and we also provide you method that if they are not on mainnet, will directly point to the rough testnet for you to check all the transaction there. So the gas prices, we put the 120 token there. And all things look good. Successful raffle create from our Albert 2 address. And also we have to check that here, the deployed raffle place. So put the raffle here. And you can find that the name workshop is where our like our file name here, it fetch it and get the app ID and also get our admin account. So we now have a Raffle app ID environment. So we have to build our code and put on it. So here we start building it. For native Linux, you can directly use Oasis Raffle build, but currently only supporting Linux environment, so we can use Docker to make your like a Linux environment and run all the stuff there. So just wait for it to download some code, and we can see the next part. After we build it, we already make sure our code integrity, but how about our secret key? So here is another way. You can echo your token back there and use a secret set token to send it to the OASIS. I think it's not OASIS. It's more like, you should specify your token. I'm not sure. Yeah, token is here. But I think it's already exported, so maybe we can directly use it. Yeah, we're just setting it. Yeah, I think the first part is already setting all our raffle token on it. So let's take a look at our architecture. You will find that we have the workshop default ORC is from our built-in, is from the previous build function. And you can see in the raffle YAML, directly case raffle YAML, you can see that here have a secret, which we also created by the raffle set secret setting and put it on chain. So here is also the secret. So, but once we build, we did not let it raffle know we have a secret, so we have to update it to put our secret to on-chain verification. OS is raffle update. So you will ask you to send a transaction and make all things integrity again and be confirmed by the Sapphire blockchain. Execute successful. And we can directly deploy on-chain. But it will take a little bit of time because it will ask the machine to, you will point to some small set of machine, and that machine will get your Docker Compose and set up the environment for you. So before it's successfully built, I think we can just test it now. Yeah, what I expect is it will fail because it's not successfully deployed. But we can go back here, and once it's deployed successfully, we can check hello again and test it whether it worked well or not. So, but it will take a little bit time. So, but I think the time is not enough for us. Yeah. Let's just waiting for it. And once it deployed, you can use OSS Raffle machine show or like a other function for it to tag into what the machine logged from it, and you can see it from different doc. I think will be the deployment, deploy show over, deploy will direct like a machine show. You will give you a name, provider, and also the information about which machine you run on it there. And you can get log from it. If there have some problem, you can log it to the machine. You can get a log from the machine. Yeah. And it's all things about OS's Raffle demo. And if you want to build your own like private off-chain heavy computation app, you should just use Raffle and build your own image. You can write in Python, you can write in Rust, or anything, any language you want. Whether you want, you can write it in Docker image and just put it onto and make it raffleized and deploy it. And all of Node will run the text for you, so you can build Oracle gaming and other AI stuff on it. So it's very good, and I encourage all people to work on it And that is our today demo. So yeah, thank you everybody.